So let us talk about DNS today. This DNS domain name system is basically a large database that it resides on various computers, and it contains the names and IP addresses of various hosts on the internet and various domains. So this DNS domain name system is used to provide information to domain name service to use when queries are made. This domain name system is hierarchical distributed naming system for computers, services, or any resource connected to the internet or a private network. Most prominently, it translates more readily memorized domain names to the numerical IP addresses needed for the purpose of locating and identifying computer devices and devices with the underlying network protocols. So this mechanism provides distributed and fault-tolerant service and was designed to avoid a single large central database. The internet maintained two principal namespaces: the domain name hierarchy and the IP address space. So the domain name system maintains the domain name hierarchy and provides translation service between it and the address spaces. So this internet name servers and communication protocol implement the domain name system, and the DNS name server is a server that stores the DNS record for a domain. A DNS name server respond with answers to queries against its databases. So the most common types of records stored in this DNS database are the DNS zone authority, IP addresses. This is like this. I'm going to tell you more about this. SMTP mail exchanges, name servers, pointers for reverse DNS lookups, and domain name aliases. So although not intended to be a general purpose database, DNS can store records of other type of data for either automatic lookups such as the DNSSEC record or human queries such as responsible person RP records. And as a general purpose database, the DNS has also been using in combating unsolicited mail by storing a real-time black hole or blacklisted list. So the DNS database is traditionally stored in a structured zone file. This is very important. Structured zone file. Let us go to the history. ARPANET utilizes a central file called host.txt. It contains the name of addresses mapping and it's maintained by SRI's NIC. Now administrator email changes to NIC. NIC updates this host.txt periodically, and administrator FTP it downloads host.txt. So as the system grows, host.txt had problems like scalability, number of collisions, and consistency. So in 1984, Paul released the first version of what we call today as the DNS. And the domain name system, what internet users used to reference anything by the name on the internet, because numbers are very difficult to understand, which are called the IP numbers. So if the names are good, then because those are understandable also. The mechanism by which internet software translate these names to attributed such as addresses. So names to addresses. This is what DNS is all about if you just want to learn in one line. A globally distributed scalable reliable database, which is DNS, and it comprised of three components: a namespace, server marking the namespace available, and resolvers like clients which query the servers about the namespace. Why we need DNS? DNS, we need to have a database where the information about the systems are stored as a name, and global distribution because internet is everywhere. Coherency lose, and scalability, reliability, and dynamicity. All these aspects for which we require this DNS. What DNS is a database? The keys to the database as domain names. For example, this is a website. This again, a URL. This is again a URL. All these names or type of point values are there. So over this much number of domains names are stored, and this is huge, ever increasing because it is scalable. And each domain name contains one or more attributes known as resource record. And each attribute individually is retrievable. This is very important. Each is retrievable by itself. The global distribution data is maintained locally but retrieved globally. So no single computer has all DNS data. Security aspect is also there. And DNS lookups can be performed by any devices, and remote DNS data is locally cacheable to improve the performances. Then losing the coherency, the database is always internally consistent, means each version of a subset of the database has a serial number, and the serial number is incremented on each database change. The changes to the master copy of the database are replicated according to the time set by the zone administrator. And cache data, this expires according to the timeout set by the zone administrator. Now, this scalability, no limit to the size of the database. One server has more than this number of names, not a particularly good idea, but no limit to the number of queries. This number of queries per second handled almost easily, and queries distributed among masters, slaves, and caches. Reliability is also there as far as DNS is concerned. Data is replicated, data from master is copied to the multiple safe slaves, and clients can query master server, any of the copies at slave servers. Client will typically query the local caches, because cache, if it is available in cache, it will be received. Otherwise, it will go to slave, or rather, not if it is found in slave, it will go to the master. So DNS protocols can use either UDP or TCP, means connection oriented or connection less. And if UDP, DNS protocol handles transmission, sequencing, etc. Then dynamicity is also there. Database can be updated dynamically. That means adding, deleting, modifying of any record can be done. And modification of the master database triggers replication. That is, only master can be dynamically updated, and it creates a single point of failure. So DNS components include namespace, the resolvers, and name servers. As we earlier discussed, namespaces are specification of a structured namespace and data associated with the names. Resolvers are the client program that exact information from the name servers or extract information from the name servers. While name servers, the server programs which hold information from the structure and the names. Then we have namespace. We have flat namespace and hierarchical namespace. In a flat namespace, as a name is assigned to an address. A name in this space is a sequence of characters without structure. While in a hierarchical namespace, each name is made of several parts. The first part can define the organization, the second part can define the name, the third part can define the departments, and so on. These are the resolvers. The resolver maps a name to the address and vice versa. So this is like this, a query and then the response. This is the iterative resolution, that what is the IP address of, say, some website. The client send this to UDL server or iterative response. I don't know, try at this. Then again it goes to somewhere else. If this is being tried, the a3.nstdl.com. Then iterative response, I don't know, try this. A root server, I don't know, try at this. And finally at going to the other server, and again it is sending you to some other server, nsl.google.com, and now the IP address of google.com is this. So this is how from your cache to the various slaves to the master it reaches, and you essentially or finally get the IP address of www.some.com, some website. I have just given an example, it may be anything. And this is a recursive resolution. What is the IP address of some website? It goes to edu server, it gives to root server, it goes to com server, it goes to the website server, and then again back, it is given back, and finally to the client. So this is the recursive request and the recursive response, that the IP of some website is this. This is the type of name server. Okay, this is the name server. We have authoritative data, cache data, and agent. From zone data file, we have also master server. This is the architecture. So this is the zone transfer. This is the zone transfer. And these are the name server. Again, some query from the resolver to the agent, the response from the authoritative data to the resolver. And using other name servers, some query is given. Then this query, the result is given by the agent to the arbitrary name server, and the response is given to the cache data, and the response is again given back to the resolver. So this is how a query is made in cache data. So resolver send the query to the agent. The response is received from the cache data. Thank you so much. This was just a bit idea about DNS and its working. Take care.